Welcome to the another interesting session of 11th chemistry. Today's topic of discussion is dynamism in chemical reactions. It is to understand the movement of atoms in reacting molecules. If you compare solid state, liquid state and gaseous state, liquid state is much easier and faster state. And in this state, chemicals move comfortably. When they move comfortably, they undergo collisions. When they undergo collisions, they undergo transformations. When they undergo transformations, reactants converts into molecules. For this reason, we have to carry out reactions in solutions. That's why it is called as dynamism in chemical reactions. Here are some reasons. Most reactions occur in aqueous solutions because water is easily accessible and dissolves many substances. In chemistry laboratory, we carry out reactions in water. Why? Water is the universal solvent. In water, many chemicals dissolves and water has polar nature. Because of the polar nature, because of its ability to dissolve many chemicals, and because of its dielectric constant, what we are going to learn in the next chapter, water is called as universal solvent. Chemicals mix more completely when they are dissolved, resulting in faster reactions. Always you adjust concentrations and temperature for optimal results. Here we can understand whenever we prepare solutions, how much strength we require, how much concentrated we require, how much weak we require. Depend upon our requirement, we can change the concentration and at what temperature. By increasing temperature or by changing temperature, what happens on the concentration. For all these reasons, we have to carry out reactions in solutions so that we will come to know its concentration under what conditions. In organisms, many important substances are dissolved in water. Organisms must maintain certain concentrations of solutions. One example is pancreas keeps concentration of sugar within a certain range. Our human body is a natural laboratory. Many reactions are taking place. Maintenance of pH, formation of urine, maintenance of sugar level, all these are reactions which are taking place in solutions. So every day, every moment, our body maintains the sugar level. Slight variation in the sugar level will tell us that body is not functioning properly. For this, we have to consult a doctor. Therefore, reactions in solutions plays very important role in chemistry. So what is the conclusion? Conclusion is it is important to understand as how the amount of substance is expressed when it is present in the form of a solution. Concentration of a solution means it is the known amount of a solute in a given amount of solvent. That is called concentration of a solution. There are 4 ways of expressing concentration of a solution. These 4 ways are mass percent, mole fraction, molarity and molality. Let us discuss one by one. Number 1, mass percent. Percentage of a solute in a known amount of a solvent. So that solution forms, that is called as the mass percent, and we calculate in terms of percentage. For example, 2 gram in 95 gram, for 100 how much, like that. That is called mass percentage. Mass percentage is one way of representing the concentration of an element in a compound or a component in a mixture. You please hear, mass percentage is one way of representing the concentration of what? The concentration of an element in a compound. How much oxygen is there in water? How much carbon is there in the methane? So to express the percentage or the concentration of an element in a compound, or the concentration of a component in a mixture. Soil is a mixture. In the soil, how much of calcium is there, how much of iron is there, depend upon the percentage of the soil. We take a decision to grow for this soil which crop is the better. So to express the concentration of a component in a mixture, we use mass percent. Mass percentage is calculated as the mass of a component divided by the total mass of the mixture multiplied by 100. We will see the formula. Mass percent is equal to mass of solute by mass of solution into 100, because we have to calculate in terms of percentage, uniform calculation. So this soil contains 10% of iron. Other soil contains 15% of iron. So the soil which contains more percentage of iron is better. It is called magnetite soil. So for this soil, this crop is better. They will prescribe you particular crop. So therefore, always we express concentration in terms of what? Mass percent. This is one way. Now some examples are there to understand the mass percent. Example number 1 is 6 gram of urea was dissolved in 500 gram of water. Calculate the percentage by mass of urea in the solution. Here 6 gram of urea dissolved in 500 gram of water. Formula is what? Mass percent equal to mass of solute by mass of solution. 6 by 5 not, why 5 not 6? It is the mass of solution. He has given 500 gram of water. In the 500 gram of water solvent, 6 gram urea is there, which is a solute. So 6 gram solute plus 500 gram solvent water together, it is 506 is the mass of solution. So he has taken 506 in the numerical. So 6 by 506 into 100, that gives you 1.186%. This is the what? This is the percentage by mass of urea. Now second example, 34.2 gram of glucose is dissolved in 400 gram of water. Calculate the percentage by mass of glucose solution. Method is same. You please work out. This is regarding the prepared by dissolving certain amount of solute in 500 gram of water. The percentage by mass of a solute in a solution is 2.38. Calculate the mass of solute. Here he has given percentage by mass. So therefore we know percentage by mass, but we don't know the mass of solute. Okay, so let us calculate the mass of the solute. Formula is same. Percentage by mass equal to mass of solute by mass of solution into 100. Percentage is given 2.38. Okay, here it is 2.38 in the numerical. We don't know the mass of solute, so we'll take it as x. So x by x plus 500. What is the 500? 500 is the mass of solvent. In this solvent, how much gram is there? We don't know. So it is 500 plus x. So therefore, it is x by x plus 500 into 100. So please simplify. We will get answer equal to, because it's very easy simplification. You know the algebraic expressions or quadratic equations. So using all those mathematical operations, you calculate it is x equal to 12.19 gram. In the same way, we'll go for the fourth example. Calculate the masses of cane sugar and water required to prepare 250 gram of 25% cane sugar solution. Here also he has given percentage by mass. We don't know how much is the solute. So, but here he has given what? Here he has given to prepare 250 gram of 25% cane sugar solution. So this is mass of the solution, not mass of the solvent, because the statement says to prepare 250 gram of 25% cane sugar solution. In this solution, how much that sugar is there? That is the question. Therefore, 250 is the mass of the solution. So solve it. You will get answer for mass of water equal to 187.5 gram. Now this is example number 5. Calculate the percent composition in terms of mass of solution obtained by mixing 300 gram of 25% solution of ammonium nitrate with 400 gram of 40% solution of solute X. Here he has given two solutions. You have to mix these two solutions and make a main solution. Okay, right. So mass of ammonium nitrate in the solution equal to what? He has given 25% solution of ammonium nitrate. Okay, how much it is? It is 300 gram. So in the 300 gram of ammonium nitrate, the percentage of ammonium nitrate is what? 25%. That means, so mass of ammonium nitrate equal to 25% of 300 equal to 75 gram. In the same way, mass of solute, another solute X, that is 40% of 400 gram. Here it is. That gives you 160 gram. So 75 is ammonium nitrate, 160 is the X. Total mass of solute equal to 235 gram. This is the mass of the solute. Now what is the mass of the solution? One solution is 400 gram, other one is 300 gram, together 700. So mass of solution is 700 gram. Now formula, percentage by mass equal to mass of solute by mass of the solution into 100. That gives you 33.57. So in this way, we will calculate mass percent of a particular solute or a solvent or a solution or whichever is required depend upon the what he has given.